Hi folks, so today we're looking at completing the square. Why is completing the square important? Well, it's important because it allows us to define the point at the bottom of a curve, the easiest way to get there. And it's a process that once you get used to it, it's quite a fun little process to go through. At first it may seem very complicated, but it's not that tricky really, you just have to be careful. Right then, completing the square, we've got 4 problems we're going to have a look at now. By all means pause the video and see how far you can get on them. In the top corner I've done a little diagram to sort of show why it's called completing the square. Completing the square we would often do for something like x squared plus 4x, in which case if you look at this you've got a square that's x by x and then it's plus 2 on each side. Because you get 2 times x for the area of that rectangle and 2 times x for that one, in order to make up the whole of this larger square we would need to add another 4. So this would actually be the solution to, if you were to complete the square for x squared plus 4x, you would have to say, well, that's going to be x plus 2 squared, but that's going to give you 4 too many, so then you take 4 away. So taking the 4 completes the square. It's nearly always something you've got to take away to make it actually a square, because otherwise you're getting too much there. Okay. Because most things aren't squares, are they? So we're making it as if it was. And then it's got this big use, as I was mentioning, in finding the turning point of a square, but we don't of a curve, but we don't need to worry about that right now, just how to do it. So x squared plus 8x. The first thing we want to think about is that we are just going to halve that number there, because if we were to square that bracket we would get 4x plus 4x is 8x. But because we've done that, the number that we've halved, we're also going to have to take that squared away, just as here 2 squared was 4 was what we had to take away, 4 squared. So we can say that x squared plus 8x is like that, but if you take 4 squared away, and then all we've got to do to simplify that a little bit is square 4, and that gives us, take 16. It gets a tiny bit more complicated when you've got odd numbers, because odd numbers don't halve into integers, do they? They halve into fractions. And I would say at this point, fractions are your friends. So I'm going to halve the coefficient of x as I did before, so that's going to be squared. Then I'm going to say that needs to be, we need to then take away that squared. So what's that going to give us? It's going to give us x take 3 over 2 squared, take 3 squared is 9, over 2 squared is 4. And when you get to A level, you're not expected to put that in its as a mixed number, and nor are you if you're given that one at higher GCSE, it would be absolutely fine to leave it like that. Right, on to the next. Now when you've got a coefficient of x squared, I like to put a square bracket into what's going on. So what we're going to do is we're going to say, right, this is going to be, and then so what I've done is I've taken a factor of 2 out of both of those. Now sometimes it's not just simple factorising, but we'll come on to that on here. I'll be quiet about that. Let's just do one thing at a time. So we've taken that factor out of there, and then we need to complete the square for that bit inside, and don't worry about the big bracket for now. So that's going to be x take 6 over 2 is 3 squared, and then we're going to have to take that number squared away as well. Now at this point you've got to be careful, and I'm going to say very often people miss out this next line of working and then they make a mistake. 3 squared is 9, so it's take 9. And very often people forget this bit of working and they end up with take 9 as their final thing. But can you see where that mistake's going to leave us? We want 2 outside the x take 3 squared bit. But we need to multiply that. 2 9s are 18, so it's negative 18. And it's important to do that much because if you were trying to find, if you had the curve y equals 2x squared take 12x, and you were trying to find the turning point of that curve, so that bottom bit there, you would need the x value that makes this bracket equal to 0. This 2 is irrelevant to that, so that would be 3, because that makes the bracket equal 0. And your y value will be what that y value is when x is equal to 0. And that's going to be negative 18, not negative 9. So that is important. Right. One more to have a look at here. So, very often, it's quite a good idea just to do that first of all. Think, right, I'm not going to worry about that plus 3 right to the end. Then I'm going to take a factor of 5 out because I've got 5x squared. 5 goes 3 times into 15. And notice I haven't taken the factor of x out, as I didn't do there either. Because I'm now going to complete the square for that inside the square bracket. So I'm going to have x take 3 over 2, as we did over there. Take 3 over 2 squared. Leave that all inside the big bracket. And then I've just got the plus 3 outside of it. So take your time. Don't try and do it all in one big go. I'm going to leave the big bracket there for now. And I'm going to expand my square bit here to get 9 over 4. And then I'm going to go one more time. I'm now going to get rid of the square bracket. And I'm going to remember to multiply the top bit by 5. So 5 times 9 is 45. And then we're adding 3. Now 3, at this point, I'm going to change into, well, that would be 12 over 4, wouldn't it? Because 3 is 12 divided by 4. If I times top and bottom by 4, and then we keep it as a fraction in our answer. It's a more normal way, but you can do it as a mixed number if you prefer. Take 12 from 45 would be 33, so it would be negative 33 over 4. But if you wanted to leave that as minus 8 1/4, that's fine. It's just not what we normally do. Here's a slightly different problem. Solving an equation by completing the square. Now, we could do this, or we can't do it by factorising because it's not one that factorises. But you could do it using the quadratic formula, couldn't you? Except that they've told you that they want you to complete the square to do it. And this can make solving equations a little bit quicker, actually. So it's another way of finding the roots of a curve, where the curve crosses the x-axis when y equals 0. Anyway, this is what you're expected to do. So we're going to do the same basic idea. You could say, right, we're just thinking about this bit, aren't we? So we're going to say that we want this to be x plus half the coefficient squared, take that away, plus 10 is equal to 0. Then if I take the bracket away and at the same time do 4 squared, then that takes 16 plus 10 equals 0. Well, that equals minus 6, doesn't it? Or negative 6. So I'm going to add 6 to both sides to give me that equals 6. And at this point, because that's squared, I could attempt to solve it by taking the square root of both sides, couldn't I? So x plus 4 is going to equal the square root of 6. At this point I should write plus or minus, because actually I'm not sure if you know this, but if you write that, that actually means the positive square root of 6. When you take the square root, you've got two possible answers, and if you want the negative of that, you need to, the negative one, you need to put that in. So we're going to write that as plus or minus root 6, and then to find x I would just need to take 4 away. So x is going to equal root 6 take 4, and x is going to equal negative root 6 take 4. And that's in third form. It could also say giving an exact answer would be another way of asking for third form in this case. It's also more normal actually to write it the other way round and put the third after the natural number. So that would be negative 4 plus root 6, and that would be negative 4 take root 6, but it doesn't actually matter. Okay, time for another one. Right, so this is going to be the last example we do. So this is solving this equation as well. Also, if it's an equation, it needs to be equal to 0, doesn't it? Right, go for it. Give it a go. So hopefully you've thought about the fact that we're trying to do this, and then we're going to take a factor of 2 outside of there, aren't we? So that's going to give us 2x squared take 4x plus 7 equals 0 out there. Then let's do the in fact I could have done that. No, that is right. X take 2, halve it, square it, then take it halved. What am I doing? That is the halved squared away as well, and then add 7 is equal to 0. Right, before we remove the big bracket, I know I'm sure a lot of you have been trying to do it without, but it's so easy to make a mistake. Please, please don't. Then now we remove the square bracket, giving us negative 8 plus 7 equals 0. Negative 8 plus 7 is negative 1, isn't it? So that's going to give us 2x take 2 squared is equal to positive 1, if we add that to both sides. Next up, divide by 2. So that's a half. Then we're going to need to do the square root of that, plus or minus the root of a half. I was almost thinking for a moment there that the root of a half was a quarter, but of course a half is the root of a quarter, isn't it? Because a half times a half is a quarter. So that is a third. Then we're going to add 2 to both sides. So x is going to equal 2 plus the root of a half. X is going to equal 2 take the root of a half. There'll be the two positions on the x-axis that the curve of y equals 2x squared take 8x plus 7 equals 0. And actually another little note on that, it's not quite the nicest way to write the root of a half, because with surds, just as with powers, the square root of a half is the same thing as the square root of 1 over the square root of 2, and we know that the root of 1 is 1. We can write it as 1 over root 2. And x will be minus 1 over root 2. And if we wanted to, we could actually go into that and get rid of its, rationalise its denominator, couldn't we? Which the calculator will do for you as well if you want to. Okay. All you need now is some more questions to practice. So they'll be coming up in a moment. Right, here's your questions. Pause the video, give them a go. Right, so here's the answers, apart from the answer to 4. So pause the video and see how you got on. On some of these over here, you might have written it as a fraction over 2 or all sorts of different things. So have a little close look to see whether or not you've actually just got it right, but in another form. Right, so this one here I thought might cause some difficulties. First thing I would do is put it into the order with the x squareds first of all. So negative 0.4x squared plus 0.8x plus 2. Then say, right, I know I want to take a factor. I know I want to be putting that bit in a square bracket, and I'm going to take the coefficient of x squared out. Now it's a strange one, but let's just take it out anyway. You may notice that 4 goes quite nicely into 8, so 0.04 is going to go 20 times into 0.8. So if we divide by negative though, it'll be negative 20x and then the plus 2 on the end. Then we just go through the same process. So we've got that outside the bracket, don't worry about that for yet. And then inside the square bracket, we halve the 20x, get x, take 20 all squared, take 10 squared, which is 100, plus 2. And then we're going to say, right, and x take 10 squared, take 100, plus 2, then on the line underneath there, just about got room. I am going to take the square bracket out now, so negative 0.04 x take 10 squared, multiply that by that is going to give me a positive 4, isn't it? And 4 and 2 is 6, so I could then say, my final answer, because that's a negative, it would be nicer to put the constant first of 6, take 0.04 x take 10 all squared. And that's it. Well, I hope you got on okay with that, folks. If not, just go back and go slowly through it and repeat it until you're there. Okay, folks, cheerio.